All right, this is practice 7, simplifying rational expressions. So first, let's define what a rational expression is. It's a fractional expression of polynomials. So again, to be rational, it has to be simplified in the form of polynomials. So example, over to the left, I have this one. Again, the top and the bottom, the numerator and denominator of both polynomials. Same thing with this, the numerator and denominators are both polynomials. So those are both rational expressions. This example right here is not a rational expression. This is a polynomial, but this is not. So if you remember, a polynomial has to have a positive exponent, and so this obviously does not have that. So that is not a rational expression. It is a fractional expression, but it's not a rational expression. So let's go to this. Algebraic expressions cannot be defined for all values. So in other words, what we need to do is basically find the domain. You know, what numbers, if this was a function, if we were graphing this, what functions does this function, does it work for? Or better yet, what can we ask, what does it not work for? So this first example, if you notice, this x could be 1, it could be 5, it could be 17.9, it could be any number, except it cannot be 0. It cannot be 0. Remember, you cannot have a 0 in the denominator, and so here it's all real numbers. So if you remember the symbols for all real numbers, looks like a capital R with a slash through it. So it's all real numbers, x cannot equal 0. So this example right here, notice what x could be anything here, but it has to be greater than 0. So here it can be greater or equal to 0, and here x cannot equal 5. Cannot equal 5. So if you notice the way that we're going to write the domain, we're going to write it like this. Remember that it's the braces refer to sets. So a set of numbers referring to x. So the x bars, it just lets you know it's referring to x. And it's basically all real numbers, every single x value except 0. So x cannot equal 0. So the same thing with this. You know, again, the braces on the outside, and then x, and then you have the bar. Again, that just refers, it's referring to x, and then x cannot equal 0, and x cannot equal 5. I think I'll do that. So that's the domain. And by the way, I want you to notice this expression is a fractional expression, but it's not a rational expression because of this guy right here. That is not a polynomial. All right, so again, if I had this, I want to find the domain of each one of these expressions. So here we're talking about the domain of x's. If this was another variable like w, we'd put a w there. So you know, that's all that's referring to. And this is all real numbers. Every single number x will work on this one. Now on this denominator, on the second example, notice this. If I factored, let me write it over to the side here. So here I have x. X could be anything up top. But on the bottom, if I factor this would go to x minus 2 and x minus 3. So notice on the denominator, I cannot have 0. So here, x cannot equal 2. Here, x cannot equal 3. So this is the set of all the x values, except x cannot equal 2, x cannot equal 3. And the same thing here. If you notice here, x cannot equal, this is actually the same problem we just got done doing, so on the previous page. So here, x bar, and then x is greater or equal to 0, and then x cannot equal 5. All right, so let's talk about simplifying rational expressions. So here I have rational expression because they're both polynomials, and then what I'm going to do is simplify this because a lot of this can be done by factoring. So again, what you have to do is be fast at factoring and of course accurate at factoring. So once you factor this, you're going to get this, and then you have to ask yourself, what can I simplify? Well, notice I have the x minus 1s that can simplify. And then what remains is the simplified rational expression. So our goal is to simplify it and make sure that we know what we're doing. Now, by the way, just talking about the domain, you have to look at the original problem. And so the domain is, you have to find the domain of this. If I ask you to find the domain of that, you would say x cannot equal negative 2, and x cannot equal positive 1. Not equal. Right. If you look at just the final answer, it looks like x cannot equal just negative 2, but you have to look at the original problem, because the original problem, if I try to plug in positive 1, it would not work to be able to do that. So you have to look at the original problem to find the domain. All right, so again, on each of these, you're going to basically factor if it can be factored, and then simplify. All right, so again, I factored each one of those, and then we're going to look for anything that can simplify. And we noticed that we have an x plus 4 with an x plus 4 there. We also have an x minus 1 and an x minus 1 crossed out. And that's it. So we're going to rewrite our answer as one fraction. And that would be my final answer. And again, if we ask for the domain, you look at the original problem. And again, this is the original problem, okay? All of this is the original problem. It's just in factor form. That way we can see that x cannot equal 1, and x cannot equal negative 4. All right, so you look at the original problem. Don't just look at the simplified rational expression. All right, so here again, what you're going to do with division, you're gonna factor this one over here. So this is x minus 4. This is x plus 2, x minus 2. But remember, with division, you change it to multiplication, and then you flip the fraction. So the denominator will actually become the numerator. So notice I factored this to that. And then I'm going to factor the numerator, and I'm actually going to put that in the denominator. And then after that, then you can simplify any expression. So the x minus 4 is crossed out, the x plus 2 is crossed out, and that is it. So the only thing that remains is x plus 3 on the top, and then you have x minus 2, and then x plus 1 on the denominator. All right, now when I get to this is adding fractions. Let me remind you of some basic things when you add fractions, okay? So even if I had like 1/2 plus 1/3, that is not 1/5. Or some students even say 2/5. You cannot add fractions that way. You have to get a common denominator. So remember back, even if I did 1/2 plus 1/3, if I got a common denominator, I would find the LCM, the greatest common denominator here. And then you'd get, that would be 6. Now, once I find it, and a lot of times you can just multiply them, and that would be your common denominator. So once you find the common denominator, then you find what's missing. So 2 times 3, and here would be 2, and then you multiply. And then you finally add the common. How many 6s? 3 6 and 2 6 means you have 5 6. Now, on this problem right here, the same thing, the common denominator is, a lot of times we can find it just by multiplying them together. And then you find out what's missing, just like what we did earlier. So what's missing here is the x plus 2. And then use the distributive property. And the same thing here, what's missing is the x minus 1. And again, the denominator, common denominator, they both have x minus 1, x plus 2, so that means we can add the numerators together. So if we add these two numerators together, we get x squared plus 2x plus 6. Again, I combine this and this together to get to my final answer. All right, this one right here, same idea. What you have to do is be able to factor these, and then you'll be able to see the common denominator. So notice I have x plus 1 repeated. So there's 2 of them involved, and then also I have an x minus 1. So again, you're trying to find your greatest common denominator here, or your LCM, And so x plus 1, x minus 1 is your, what your common denominator would be. So what's missing from here to here is an x plus 1. And what's missing from here to here is an x minus 1. So this is going to be 1 times that. This is going to be 2 times this. But remember, you're actually distributing a negative 2 because of the subtraction. So the common denominator again is x plus 1. Actually, let me write x plus 1 squared, and then x minus 1. And then you're just going to combine those together to get to your final answer. And simple mistake there. This should be 3. 2 plus 1 is usually 3. So yeah, so this would be your final answer to be able to add those fractions together. All right, again, what you want to do on this, just concentrate. It's one big fraction, but so look at just the numerator and add those together. So this would be x plus y plus like 1 over 1. Find your common denominator, which is y. Add those guys together. So this is going to be x plus y over y. Then look at this. Let's do this in blue. So 1 minus y over x. Your common denominator is x. So this is going to be x minus y. X minus y over x. All right, so you have your two fractions. So basically, and remember, we're dividing. So we're going to take the black one up there, so x plus y over y, and we're dividing it, which is the same as multiplying by the reciprocal of the other one. We're going to do that. And then you're just basically going to multiply those. You don't need to use the distributive property. And this is your final answer. Nothing can simplify. That is your final answer to simplify that expression. All right, this right here, if you remember what you've covered before, is that you want to get rid of that irrational expression. This is not rational. This is an irrational expression. And we're going to multiply it by its conjugate. So 1 minus the square root of 2 and 1 minus the square root of 2. Again, I'm just multiplying by 1. That is a factor of 1. And so here we're going to get 1 minus the square root of 2. And again, if you FOIL this, so here we're going to get 1 plus the square root of 2 minus the square root of 2, and then minus 2, if you FOIL that. So 1 minus the square root of 2 over negative 1, because these cross out. Then you remember you can't have a negative on the denominator, so it's basically negative 1 plus the square root of 2 will be your final simplified answer. And just a quick comment, these are common algebra mistakes. Teaching for many years, I see these all the time. Study these, make sure you don't make these common mistakes with each one of these. Every single one of them, I could spend like 5 minutes on each one of these, but I see them as a teacher. Students make these common mistakes, and just look at each one of those and notice you cannot do those mistakes to make sure that you understand the full properties of exponents and square roots, and even adding fractions. Even this one right here, again, several people just add those denominators, and you can't do that. So again, avoid this. That's how you simplify rational expressions.